Okay, the final thing we'll do then is to use the information that was deduced from above and sketch a graph that satisfies the given properties. One of the first things we can do is to plot the 2 points that were given, that we have -3, 4 and 3, 1. Now we also know that we have an absolute maximum at x equals -1, and since the first derivative doesn't exist there, we don't have a horizontal tangent line, and we could deduce that that has to be a sharp turn at that point. It can't be a vertical tangent because the function would have to go up further from that point. So it has to go up to a particular point and then come back down. So the function is increasing up to -1 and then decreasing after -1, and the derivative doesn't exist there, so that has to be a sharp turn. We don't know exactly where that is on the y scale, but we'll just plot a point at x equals -1 to be an absolute maximum. And we'll say that's at y equals 8, but it doesn't really matter. Next. Now we know that the function is increasing from -3 to -1, and we'll look to see what its concavity is on that interval. And since the second derivative is positive on the interval from x equals -3 to -1, that means it's concave up to that point. So we draw a line segment that is increasing and concave up. Next, the next interval we want to work with is from x equals -1 to x equals +1. We do know that we have a horizontal tangent line at x equals 1, but the function is decreasing up to that point and decreasing after that point. So we don't know exactly where the y value is. We'll pick an arbitrary point, but we do know that it has to be above y equals 1. And so we arbitrarily set that to be at y equals 4. Once again, we know that from -1 to 1 the function is decreasing and concave up, but has a horizontal tangent line at x equals 1. And so we construct a line segment that has those features. The final segment or final interval is between x equals 1 to x equals 3, and we know that on that interval the function is decreasing and it's concave down, and so we draw a line segment that fits that criteria as well. And so that meets all the criteria that we have. The function is concave up from -3 to -1. It's concave up again from -1 to -1 to +1, and concave down from x equals 1 to x equals 3. It's increasing from x equals -3 to -1, decreasing from -1 to 1, then has a stationary point, a horizontal tangent at x equals 1, and continues to decrease until x equals 3. Right, so we do know that we have a sharp turn at x equals -1 because the first derivative doesn't exist there. The function was increasing up to that point and decreasing after that point. So it can't be a vertical tangent. It has to be a sharp turn of some sort there. And the graph that we have meets all of the criteria in the requirements above.